I believe the most of the student here, and also the who are attending through the Zoom. So it's not the first semester, so I don't have to explain the situation and everything. You guys understand the internal problem and the external problem, but what we can do is the study, okay? Without the preparation, no matter what happens, at UB or out of UB, so we cannot survive. So please build your the career and the experience, and then you guys can continue the work. Okay, so this is the CPSC 652 Hadoop and the NoSQL database. Right now, I'm currently using the Zoom for those who are attending remotely, and also I'm recording the Zoom meeting. Also, I have a GA to record the video, because the Zoom probably very limited based on my last the class for operating system. So sometimes I can use the out of bound. The student cannot see, and also surprisingly the whiteboard is very clear. So using the webcam, I didn't realize that my webcam is such a high quality, but the angle is not so good. So if you wanna see the lecture clearly, you can watch the video that will be available 1 or 2 days after the class. So I believe the GA are working very, very diligently to upload the video on YouTube channel. I'm going to share that YouTube link with you after the meeting. So don't worry about too much, even though you cannot catch up everything in the class through the Zoom, but hopefully you guys can catch up using the recorded video. Also, let me start with the, where is it? So, first thing is we do not have enough capacity in this room. As you can see, this room is a kind of basement, which is not so good for ventilation. I opened the door yesterday, so hopefully the circulation. Unfortunately, there's no force the ventilation in this room, I believe. So it's very hot here. So I limit the number of students in person 50% of our enrollment, which means right now I have 15 students. The maximum 8 students, including GA, can attend this class. So, but today I have only 2. Thanks so much for your coming. But in case it's more than half, so more than the 8 students, those who are not assigned cannot be here. I will be the priority for those who are assigned. So group 1 is for odd week. So we already, believe it or not, the first week was past the last week. So we are not going to have the midterm break during the faculty development day. So Monday, Tuesday, Wednesday were skipped the last week. So we didn't have a class. So this is the second week. So this is based on yesterday class roster. So Babenko, the Clayton in Arler, the Caroline, the Kasper, the Kutola, and Louis can attend the class. So then 24 as a group 1. So during the odd week. So next week you guys can attend. During the even week, so you can join the class through the Zoom meeting. The group number 2, the even week, this week is the second week. So the Umesh, the Rizwan, the Shreya Sharma, Sri Rahul the Sankala, and the Brian, and also the Mia Madhuris, and Barrett and John can attend the in-person class the even week this week and the week after, and so on. So that According to the UB campus schedule, academic schedule, the all in-person class will be ended before the Thanksgiving. Then after that, it will be automatically the firstly online class. So we will have the one time the online class, then followed by the online exam. Regarding to the exam, all exam will be online remotely. We are not going to have the exam in the classroom. So instead, you guys can take the exam. I'm not sure whether we have both the midterm and final exam. Usually, I have a one-time exam at the end of the semester for the NoSQL database. So pretty much it will be the same. So we will have the one-time final exam. What kind of midterm exam? To check the performance. So it should be the online. So I already sent out the email several times, so I'm going to remind you one more time because the safety and healthy is the top priority in this classroom. So follow the UB guideline regarding to the pandemic, under the pandemic. So you can go to the link and check everything. So wearing a mask when you come to the class, okay? Even for me, it's not comfortable. Even I cannot. The breathe is it's 95 something. So 95, it's an air and virus will be filtered. It's very hard to do the breathing, and I cannot wear the glass. But that is the best way to protect myself and my student. So please wear your mask. This is the 2.5 hour long class, once a week meeting. So it will not be easy to stay there. I'm thinking that today the short version of the class. So instead of having the break time, I'm going to have the 1 hour 30 minute or the 40 minute. The class then will end. We will see what's going on. So if the students are not comfortable and also I'm not comfortable, then we can switch to the online class maybe next week. But so far, okay. And complete the daily health assessment when you come to the campus. So I have visited my hometown Korea during the summer, and it is required, it's mandatory to stay at home the 2 weeks. Right after I arrive, even I cannot take the public transportation, using the private transportation, going to the designated area, then stay the 2 weeks in a room. So it's a mental problem. So after 5 days, I think the 5 was it's less. So first week, it's almost crazy, but after that, I got used. So because somebody gave the food and everything, I just lay down and then watch the TV. But when you come to outside, please complete every day complete the daily health assessment. At the time, using the app, Live Safe is available. Please use that. Just in case something happened in this room, we can also track the person who had the connection. So then it can prevent the spread out of the virus. Okay, then keep the social distance right now. It's also a good idea you can move to the next room, so you don't have to back where we have only 3 persons in this room. Okay, just in case. Okay. Yeah. So always keep the social distance. Also, you can go to the bathroom, but if you can stay until the end of the class, please do so. Okay, when you move in and out, so it may be risky. So first, the few weeks is more conservative. So in this classroom, if you have any symptom like the temperature, definitely, and also the vomit, I heard that the symptom of the COVID is the temperature. That's the obvious. So temperature is the signal something happened fighting inside your body. then you lose something sensitivity. It's like the special taste. You cannot feel any taste. That's the one, the not unique, but different from the other, the symptom. So, but any unusual thing, just stay at home. I'm not going to check the attendance throughout the semester. So it's a fully your choice. If you want to come to the class during the assigned day, it's welcome. Otherwise, stay at home. So if you don't want, if you are not comfortable, you can stay at home and take the class remotely online. Okay. So attendance is not the required. No attendance check. Will not be consider the grading. Okay. Including the. That doesn't mean that you can wait for the class activity. You guys need to do all the assigned homework and the project and so on. Okay. For those who want to take the class remotely, so 2 ways. You can join the class using the Zoom during the class hour. That's live. Then I always record this class using Zoom. So Zoom video recorded video will be available sometimes right away, but sometimes it takes time. Depends on how many classes are going on and worldwide, I guess. So you can take that. You can watch the recorded Zoom video or the GA. Where your name is
Amram.
Yeah. So Amram will take a video recording. Then will be available a couple of days after the class. A much better quality. Okay. And in case any exam will be remote. So all students. So to be fair. And here's the thing, the question. So I said before. So do not ask the question during the class, during my lecture. Instead, hold your question to the end of class or the chatting box. But that doesn't work early. So if you have a question, please gently ask. I think that may work. So, but if you have a class question through the Zoom, so my interface is very limited. I do not have a time to check the chatting box always. I'm going to ask the GA, but unfortunately GA is not available for this class to check the question. So for the question through the chatting box, I'm going to take care. I will try to check frequently, but I cannot guarantee. At least I will the response to your question at the end of class. But in the classroom, if you have, please do so. I don't think that hurts our safety. But do not argue with me, okay? So we don't have to try to fight with me. Don't try. And the office hour, I do not have an in-person office hour this semester. Instead, a fully online office hour. So. Mostly Monday, Tuesday, Wednesday afternoon, I'm available. So if you want to see me through the online, so you can go to the link and reserve the slot. So if you believe it takes a longer time, so you can reserve the back-to-back time slot. Each slot is available for 15 minutes. Sometimes the other student is waiting. So I should stop after 15 minutes. So if you believe that takes a longer time, you can reserve the back-to-back time slot using that link. Then send your personal link or the Google Hangout, the way to communicate. So send the link. I'm not going to use my personal Zoom link for the office hour. Okay. Okay, so pretty much that is the thing. How many students are in 7? Okay. So if you so far any questions? And also you guys can it was helpful. The student in a classroom turn on the Zoom. Then there's a question or there's a problem. So let me know if you can find anything from the classmate. Okay, then the because it's hard to see. Share. Okay, so this is the website, UB website for me. So if you go to the teaching, and there's a link to make a reservation for online meeting. And also if you click the Hadoop and the NoSQL databases, there's a syllabus. So this is online syllabus. Will not be updated. This is just for syllabus. Then I'm going to use the Canvas for any assignment, announcement, and update. So, but it's the first class, we will go over the overview of this class. So, class hour is 6 to 8:30, the New York time. So if you are not in the US, please keep checking the time difference, or you can watch the recorded video later. And then, my name is Jung-Gyu Lee. Probably you know who I am. So I'm professor of the computer science department. I'm in charge of mostly the database, data related subject, including the NoSQL database this class, the big data course, data mining class, the distributed database system, which is has not been offered the last few years because the Hadoop replaced such as the distributed database system, and also multimedia database, which can be covered in the computer vision class. So I didn't offer, but this semester I'm offering operating system class. It's cross-listed with the undergraduate operating system class, CPEG 308, and the CPSD 503. So I didn't offer the OS class last year, so but this semester we may not have an adjunct professor, so I'm teaching the operating system class. But I always enjoy to teach the operating system class, so it's much related to to understand the Hadoop system. So it will be good opportunity to know about Hadoop as well as operating system if we are taking both classes. So that's me, and this semester I'm offering this and operating system, and also Engineering 400, the senior project. So maybe next semester, the first spring semester, I'm offering the data mining, which was a disaster last semester because in the middle of a semester, so as you know, it's COVID lockdown, so we couldn't do the project. So, but maybe the next semester, even though online, I will be ready to offer the data mining class. It's fun. Then the database class also. So for those who are interested in the concentration, in our department, MSCS, MSC are eligible to declare the concentration on the big data and data analytics. So if you complete the 4 courses, Advanced Database Design 551, and the Data Mining 552, 651, Big Data, and 652, this course, the NoSQL database, are eligible to declare the concentration on big data and data analytics. That doesn't mean your major is changing. It's just on your transcript, it's concentrate on. So I heard from many of your alumni who graduate already, sometimes they need to prove whether you have experience on the big data or such a thing, but how do you prove? It's not always a certificate available. So at the time, if they can show the transcript, it's not on diploma, but on your transcript, so concentration marked. So after you finish all 4 classes, or the last semester when you are the semester when you are taking the last class, to contact me, then I can give the form. to change the major. Doesn't mean the change of your major adding the concentration. So that is the big data concentration. I have a GA this time, fortunately. The Burma, he will have for your exercise lab, but unfortunately he is taking another class, so he will be available through the online. So he will prepare for the recorded video for the exercise lab. When the exercise lab is scheduled, we will have a lecture, then we will end the in-person lecture, and recorded video for the exercise lab will be available. Then I will take care of the question and answer the next class or the online. Okay, the textbook. So you don't have to buy. Okay, every day is a change it. So even the Hadoop definitive guide is kind of the cookbook to understand the big data system, especially the focusing on the Hadoop. So, but you can get the most of such information from my lecture or the internet. So, but those who are familiar with reading a book, so there are the people who love to read instead of searching and reading from the Wikipedia. Instead, they like to read the textbook. Then you can buy the textbook. Even you can, off the record, stop. You don't have to stop. So you can find from internet. Okay, the PDF.
It's in the bookstore.
Oh, right. So I put this book is on the bookstore. It's totally up to you. It's you already paid. Okay, so you can. Get you don't have to read from it's 1,000 page long, so you can find the specific information when you need. So that is the style of the cookbook. So Tom White is one of the pioneer on such the Hadoop system. So I think after the first edition, he doesn't actually update. And also, if you need any reference book, so I think the 4, the reference book are marked. You don't have to buy. Okay, this is just a reference book. And also, most of the book are available by paying the several bucks, e-textbook and something like that. Then you can find. Okay. Okay, so you can read the course objective, so we will talk about the course objective later. The class schedule. So first week is already passed, so we are going to start from the second week. It's September 1st week. And this should be better. So, and it's a week by week. So if you see the third column, yes, this is the topic of the class lecture, and this one is a full lab. So if you can see, right now they cannot see. So let me use this one. Annotate. So this part is the lab. Okay, so if the lab is scheduled, you can bring a laptop. So those who are attending from home, just be ready. And however, to practice the Hadoop system, we are going to use the virtual machine, which means so everything is set up, so you don't have to do anything. It's based on the CentOS. Then the Hadoop is installed, including NoSQL database. So we are going to practice the Hadoop and also the HBase, Cassandra, the MongoDB. This is the Cassandra, MongoDB, HBase. Then plus we are going to use the cloud computing to practice NoSQL database. So that is the overall plan. So if the exercise lab is scheduled, so but this semester the GA is not available in person. The exercise instead he will make the video. Then you can watch the video. Then you can practice. then ask the question later. Okay, then the last column over here. So this is the kind of a reminder of the class activity, including reading assignment. Regarding to the reading assignment, you can read the assigned paper, then the 1 or 2 pages summary. So this is if I do not assign the summary, so probably you will not read. So main purpose is the first all student read it. So please don't be stressful for the reading assignment. So just for your experience, just read. So those who are not familiar with the technical paper, so this is good opportunity to read the technical paper. So if you are not familiar with such the specific topic, what is the Google file system, which is the father and sister of the Hadoop distributed file system. So this is the kind of a Bible, the constitution to build such the Hadoop system. So please read then try to understand as much as possible. Then we do your own work. So you can write 1 page or 2 pages. That's pretty much okay. Do not copy and paste. Do not search the Wikipedia. So what are they? For your understanding, it's okay, but for writing a summary, so please use your own work. I'm not going to check the high quality paper or something like that. So just I expect you to understand. And sometimes the exercise require the homework, very basic homework, to check whether you complete the exercise or not. So in case there is, you can do, then submit assign the homework to the Canvas. Or submission through the Canvas. Okay? So you don't have to email me, you don't have to email to the GA. And what else? Project. So we had the project this semester is a kind of a term project. So first part is I think we have there are more than 3,000 NoSQL databases. It's really a lot. Okay, so you don't have to each and every, unlike the relational database system, so NoSQL database is not the relational database system, which means there are a bunch of different databases. So we cannot cover each and every one. The NoSQL database, instead, you guys, I can cover in this classroom very popular, HBase, the Cassandra, MongoDB, and the GCP NoSQL database. But for the other NoSQL database, you guys can select one interesting NoSQL database. Then the research on your selected NoSQL database. Then second part is to download and install and implement the NoSQL database. If they provide object-oriented database design, then apply such a database design for the selected. By using the selected database, so you can implement some applications, so on. So very similar as the database project that you did in the advanced database design. You select the topic, or the professor gave the topic, like why don't you build the registration system? You design the registration system, then implement using Python and the relational database. Very similarly, so instead of using the MySQL or the Oracle, such a relational database, you can use selected the NoSQL database. Like I selected the MongoDB, and using MongoDB, I directly build the ABC application system. So you can design the ABC application system and collect the data or synthesize the data and create, and also you can create the front end. Okay. A lot of nowadays the NoSQL database provide the API for the front end. So sometimes they provide the visualization and transaction control. So you can build. So I know. So I do not know everything. So you guys can research and practice and implement and present. That is pretty much the semester long-term project. at the end, each student, we will have the online, the conference, the present your research, and then I'm thinking the online, the poster session. So which means the online, you prepare the using PowerPoint. So create the poster, then upload, then you can invite your friend and give the comment. Like I will give the more information about the such the project later. Okay. And any questions so far?
So project is in group or individual?
No, individual this time. So this time the individual. So it's not a huge project. So you don't have to be stressful for design. So you can create 2-3 entities. So sometimes it's called a table, sometimes it's called an entity, sometimes it's called an object, whatever. So you can create such a small database. Small does not mean the data size is small. Sometimes it can be much bigger than you expect, like the big data. But instead of put the data on your header HDFS or the Google Cloud, you can create your NoSQL database instance and upload. Let's start the lecture. And you want to start with this? Please excuse me. This is always on top, and I need to find I probably open this way. So what is the difference between the data and information? So we discussed about this topic in the advanced database design. So there are different opinions. So sometimes we can say the information are processed data. That may be true if we consider such an information as a knowledge. So like data mining is another name of data mining is knowledge discovery. So you can discover, find, mine the data to get the useful information. However, when we did advanced database design or database design, so from the information is not well structured. Sometimes semi-structured or sometimes unstructured. Like for example, information about this room. There are a bunch of information like that this is on the basement and it's not circulate the air, we are not very safe for those are the information. But that doesn't mean that is the data. When we talk about the data is like the dimension of this room. It's 10 feet by the 20 feet, and then there are the 16 desks and 32 chairs. Those number are the data. So how can in our the database design class we said the data are the useful information and related to each other. It's a structured information. So for example, when you search the Google, so we are saying we search the information. we are not saying to query the information, but when you search the data from the database, we are saying querying the data. We are not saying to search the databases, right? Searching database means searching proper database system, like that. So at that time, the difference is the data is useful information, and also when we are saying the useful, we collect and the organize and design such as structured data. So what we are interested in is more like such a data in database system. So how can we use such a data? How can the data be used in our computer system? Is there any process without data? Is it possible? Like think about the simple process like hello world. So we are going to use the Python and the Python print hello world. Even this is the data. Also, believe it or not, print itself is the data in somewhere in our memory. Okay. So in our memory, so there is the method of the object. So print is called, and then the executed, like that. So data are everywhere. Data are everything. But depending on how to organize the data, it can be the algorithm, like the structure. So because of that, we learned the introductory computer system. First time they're using the program. So most of all the introductory class of the computer science, like the first class of the CS major, like the CS 101, CS 102. So you learn the program language. Why? This is also the data structure. So for communication, to communicate between the user, sometimes computer, sometimes the user, and the computer. So we are going to use the program language. So it should be structured information for such a communication. So data are used in everywhere in a computer system. Specifically, like before that, what is the database? So please, when we are talking about the database is more like the storage. It's a collection of data. So which means we have large amount of data. So at the time we need the database. So in the advanced database design class, I mentioned many times. Why do we use computer? Why? What computer are the best? Should be fast. Fast one. Fast search the data. That's the main purpose of that. Safety, security is the next. Okay. So the main reason why we are using computer is a fast accessing, fast processing, fast search the data. If the computer is slow, you don't have to use. So because of that, when you are doing the CS, computer science research, the main hurdle, main target, main goal of the CS research is the performance. When we are saying the performance is the efficient, fast. That's the first thing. Then the accuracy and so on. If the accuracy is 100% but very slow, it takes the year to train the convolutional neural network model nobody used. That was the problem 10, 15 years before. The neural network is not the brand new one. Actually, the neural network, 25 years ago, it's already proposed. Recurrent neural network, RNN, and such a thing is already proposed, but we didn't use. Why? Because it's slow to train. So when I was a student, 2002, when I took the machine learning class, my professor said, do not use the neural network. Because it takes a long time, so it's, you cannot get the full performance of that. Even though accuracy is better than the surface vector motion, but it's slow. So we actually discard in mind the dissertation. I have used the surface vector motion and KNN rather than the neural net one. But why? Because it's slow. So speed, performance, so efficiency is the most important part of the criteria of the computer system. Database is the same thing. When we have the collection of data, a lot of data, problem is to take a time to search the data, right? Probably it will be linear search if the data are not well organized. So it takes a time based on the number of data. It's a linear. So like the brute force way. How to address that one? So we can consider the index or the different design, and then several things. So like the query optimization. Then we can implement this for the database management system, DBMS. Then when we have the large amount of data, so the main problem is the speed. So to address the problem, so we can consider such the algorithm and implement it in the DBMS system. Especially if we are using the relational model, then the RDBMS that we use. So like the MySQL and what else? The Oracle, such a thing. But what if we have the small amount of data? If we do not use the database, what about data? Data is not? No. Yes. So we have the data in the computer system. Computer. How? So think about your basic program. I is name. Is a lead. So if you are using Python, so you don't have to declare the type of data, unlike the other programming languages. That's one of the benefits of using the Python. So name, then based on the data, it will be string, object. Everything is an object, as you know in Python. So that, and then what happened in the memory? Name, object will be created in the memory, then it will be not like this one. It's just like just the high level view. So it will be like this. So even though we do not use the database system, actually the data is managed. So like if you have several names, we can create one. For example, array. There's no name of array in the Python. It's a list. Okay. So or tuple or dictionary. Very similar. Some immutable and mutable, and this is a key and value, something like that. But these are the data structure. Very similar as a database. However, database is when you have the large amount of data. At that time, another main difference between this one and this one is this is a memory based. All the data structure are in the memory like this. On the other hand, this database system, nowadays there is a memory based database system because memory is faster. But this kind such as the specialized database, that is one area of the NoSQL database that I'm going to introduce later. So memory, the database system as a NoSQL database, but this database system mostly under the secondary storage file system. Okay, benefit much bigger than this. Okay, then we can manage the data. That doesn't mean the memory-based the approach does not have such a database structure. No, it has. So that is a memory-based data structure. So that means the data and data structure, database are everywhere. So go back to this one. So far, if you already took the advanced database design class, so we have used something. We learned about the query optimizer in depth to speed up, but regarding to the model. So to speed up, to search the data, to manage the data, how can we manage the large amount of data? So we standardize. Standardize, which means, so even though I have the number of many students, each and every student are different. So they are unique. They have their own. Each student has their own characteristics. But I don't care. Because if I care about the uniqueness or the characteristic individual, the head will be explode. So I'm going to consider student as the GPA only. If the higher GPA, good student. Lower GPA, bad student. Like that. Very simple. Then I can actually decide search the student with the GPA, the 4.0, pick up, and 3.0, this is still good, so like that. So if I standardize the data, it will be much easier. Easier means it's faster to search the data. To do that, in terms of relational database model, in relational database model, so you guys need to do what? First thing is logical modeling, ER modeling. You are going to find the entity. What is the entity? So something that lead, ID, and major, and the pattern. 1, 2, the major. Then we group, and then realize this is a name, this is an ID, this is the major. What is this? Student entity. This is standardized. So even though the Lee has another characteristic, Taylor has something handsome and personal character, we don't care. These data will not be considered to be managed in this. Instead, the common information, useful information will be data. Then we define student entity. This one will be eventually, probably this much will be covered. So then, we can create the eventual relation. Relation is the table. Using the software, we can create the table. Table is type this. This is what we have done before. Good news, works well. So we can handle up to the terabyte size of data. But if we already took the big data, nowadays the size we will see later, such a size level, scale of the data is not the terabyte level. Even personal computer has the terabyte level. So mine is not. Probably yours is 1 terabyte size hard disk drive. Or the SSD, 1 terabyte is very expensive, probably. So, but 200, 500 gig is the reasonable nowadays. So it's the petabyte. No, the terabyte level was not the scale of the relation, the database. So nowadays the petabyte. So up to the petabyte level of the data, relational database is working. But nowadays big data and what's the average size of the daily produced YouTube? It's just several petabytes already, every day, every second. And what about the Instagram? I didn't use TikTok. Do you? No. I do not know anyone, including my student, who are using the TikTok, but from the news, it's very popular everywhere. Even my kids, they don't use TikTok. They know, but they said that they didn't actually install the TikTok, but it looks like very popular. Which means you are not younger generation. But such the social network produce a huge amount of data. And the sensor, there are everywhere such a sensor. So like the camera or something temperature, even so some of the universities, not UB, they are using some temperature check and such a sensor sent to the database system, storage and manage such a big data. So in the big data era, such a relational database is not actually properly working. So we need to address that problem. Also, I said to make such a big data, we can standardize model such a way. But I try to keep something other information. Lee sometimes is not only the ID and the major, I try to keep his hobby, extracurricular. And for the Potter, he's working for the club. So how do I keep such information here? In relational database, you need to change the entire model. If you change this one, so you need to change the entire. Even some of the DBMS does not allow to adding, deleting the column because it hurts the model. So it's not convenient when we are dealing with some of the extra. And who knows, this person, they may not have the same structure. They are different, right? So that's the problem. Also, go back to the relational database. So relational database, so when we talk about the relation, we will review the more details, the relational database later, because it is true, the NoSQL database is to address the problem of the relational database, which means we need to know what is the problem of the relational database in more detail. So this is a kind of overview, the high-level view of the problem of the relational database. But because you already took the relational database, you know what is a relation. Do you remember what is a relation? It's a very simple collection of column attribute or collection of data. It's a collection. Collection means actually same as what? Set. So actually the relational database model comes from the set theory. Set, you know the set. This one, natural number set, 1, 2, 3, like this one. So you know what is a set. And the relation is the same as this set. What does that mean?
It's good, yeah.
Okay. So relation. This is a relation. So what? Which means actually from the proposal by the Dr. E.F. Code, who proposed this relational model, there's no restriction using this relation, this table from the column or from the data, which means you are able to select the specific column. However, the relational database management system has been developed to search the data row. So considering number of column, number of data, which is bigger usually. Number of row is much bigger. So this kind of table shape is the kind of the use of such a table. When we think about the table, looks like the much bigger and number of few the column. So this is the data-driven approach. However, think about for the column, we put the column as a sensor. So we deploy the sensor like the humidity and temperature collecting sensor. Then nationwide. So 1 million sensors will be deployed from the airplane like that. Then they will collect every hour they send the data. But this one is a million sensor. Column 1, so first sensor. Column 2, second sensor. And the column 1 million is a 1 million sensor. So we have the million sensor, they send the data, so this is the time. So the primary key is the time. Then we can put the data like this. Okay. What we want to do is instead of finding the specific row data, we'd like to know the specific column. So which means we write the number of column is usually bigger than the number of data. Every day, if we refresh this data, it has how many? The 1 minute, one data. That means 60 times 24 is several thousand only. But this one is millions. So our approach is to find the specific column area whose the temperature is bigger than 80, something like that. But relational database like the Oracle, MySQL, they do not support this. Mostly we try to find the specific log. What if we have such a requirement? That happens. It's column-based, the database. How can we handle it? So that's the limitation of a relational database. So, plus there are other. Relational database model, it's good, still being used. Still, if you check the market share, so Oracle is the first one still, and MySQL is also belongs to the Oracle, so still, and DB2 IBM, and the top 4, 5 out of 10 is still the relational database model, still being used. Reliability, and also the works well for the online transaction processing, fast response time. But it cannot cover each and every requirement nowadays because data is changing and there is sometimes unstructured. It's not, relational model is very, very strong, too much strong. So there is no flexibility. So I gave you the Cooper example. Then, can we address this problem? So relational database cannot. So we are going to think about the different database model. So that is overall for the NoSQL database, starting of the NoSQL database. So the name itself is kind of against the relational database that people sometimes say not only SQL, but so covering the relational, this is true. Still, even though the MongoDB is popular, so still a lot of companies try to hire the person who knows MongoDB and the person does such a thing, but or based on the big data like the Hadoop, the HBase, so on. But that doesn't mean they throw away the relational database. So they still use the relational database, the front end for the online transaction part. NoSQL database is for the specific purpose, like the backend database or the kind of analytic, or the data warehousing, or document database. For so a document is also another thing. So we will see the later, but the brief story is that you know what is the HTML? So hypertext markup language. The main characteristic is a markup language, then add hypertext, REF T. In the tag, URL, hypertext is REAF. Right? Sometimes. Anyway, so there's a link. So hypertext markup language. This markup language is not the first one. Long time before, 1940 and 1950. After the World War II, so the military, the Department of Defense, they have a huge file of the document. It's a printed or typed. So is there any way to manage such a document? So they actually design. Is there any way to model or organize such a huge file of the document? And they realize that there is a title, there is the author and the time and the date and the main keyword. So they mark. It's a markup language was invented, proposed 1950, before personal computer system or internet, before the internet. Then it's called SGML and such the markup language, but it's very, very complicated. It's not widely used. Then when the people, the ARPANET and something, the military-based communication, they build the internet. Then they try to use some the standardized the document, which is called HTML. So they simplify this markup language by defining H1 is a header. They don't have the size of that. Instead, H1 is the largest header, H2 is the second largest, and the P is the paragraph, and the LI is the list. Just a few number of the tag defined. And if you agree this one, then there is a client. So you can use this markup language and the document. But this is standardized for the internet, the document. Then this has been developed. So we have the HTML 2.0 standard, 3.0 standard, like the add more the tag. Okay? Then what if we are able to search such an HTML document? This is the starting of the Yahoo, the internet search. It's very simple. The Yahoo, the search engine, this is the first seed the HTML document. Then save it. And find this hypertext link. Then visit the next one. And save it. Save it, collect a bunch of the HTML file. Then it's too many. So it takes up time to search the specific information index, inverted index, and then even index takes up time. Is there any give the rank? So page rank algorithm will be used to give the top and second and so on. What is the data? It's a document. Our information actually comes from the document, but relational database may not. But unfortunately, relational database model cannot handle such a document directly. Because of that, we actually segment. Do you remember the normalization process in the relational database? Normalization, in other words, is a segmentation. We decompose. We do not use the HTML document as it is because the relational database cannot handle. Instead, we decompose and find entity, column, attribute. Then store the data into the relational database. We destroyed the characteristic of the data document. So actually, a lot of information comes from the document. Is there any way to manage and search the data as it is, like the document format? That is the document database, like the MongoDB is the example. So that is the kind of a short history of why we need the NoSQL database. So in this method, we are going to research on what is the NoSQL database and what are the examples, what are the characteristics of the NoSQL database. It's not very complicated. If you already took the relational database, it's a kind of the extension of the relational database system.
We demand a lot of our databases, and our databases demand a lot of us. They're fragile, expensive, and tough to maintain. When things break, it can be hard to put the pieces back together at the speed of your business, and you often lose data in the process. We've all come to expect that distributed databases can't be globally consistent and scalable. But what if you didn't have to make trade-offs? What if you could have a fully managed database service that's consistent, scales horizontally across data sectors, and speaks SQL? This is Cloudspanner, a mission-critical relational database service built from the ground up and battle-tested at Google for strong consistency and high availability at global scale. At Google, we use Spanner for services that billions of people access every day.
Characteristic of this one. That is not possible in relational database. That's another drawback of relational database. So for example, cloud computing would like to address that. Keep the scalability and the reliability, and
database rows stretching across the
I
globe.
forgot another thing anyway. So that those three. It's called the spanner.
We've built Cloudspanner to be fully managed and secure. Automatic sharded and synchronous replication with low latency and schema updates without downtime means your data is highly available and reliable. Instead of endless provisioning and worrying about maintenance, you can focus on growing your business. No matter your needs, you don't have to hit a wall with your database service. Get started with Cloudspanner and build what's next.
So this is the short video clip shows the idea of the NoSQL database. So NoSQL database is not the specific. It's unlike the relational database. It's like the except the relational database, everything. If we consider the database, that's one of the NoSQL database. So that's what we are going to discuss throughout the semester. Okay, so I already introduced myself, so I'm going to skip this one. So I like this slide because this is the first computer I used, 1983. Steve Jobs actually developed this with Wozniak, but they were kicked out because in terms of business it's not successful. But he came back, then built what? The pod. So believe it or not, I had the MP3 player before Ipod. So it was developed by the Korean company. So Co1, something like that, the name. So it's smaller than even Ipod. So what they did is it's just the MP3. The device, and then small storage MP3 file, then the display. It was nice. But what's the difference between the Ipod and the first MP3 player? First design. So Ipod is the curve shape. So this is actually true. The Samsung Galaxy Note, Galaxy first version of the Galaxy, they copied. Everybody knows. So even my supervisor for my master, I got the master degree from Korea while I was working for the company. It's an evening class. So then my supervisor was the member of the something committee, and they evaluate the first Samsung Galaxy. He said they tried to the first intentionally copy because they didn't have the knowledge to build they even didn't have any concept of the smartphone or such a thing. Just to see, they try to see what's going on. The new device developed by the Apple. So they copied, but it was jackpot. People liked it. So then, actually the Apple sued the Samsung for the curve shape. That is kind of unique, the design of the iPhone. Everybody knows, but it was a lawsuit several years, but I cannot remember what is the result, but probably Samsung paid something settlement. So that. But this was also the first the computer that was developed by the Apple computer. So you can see the lamp size is 4 KB. IBM is much bigger, and hard disk drive. Interesting is usually such a personal computer price, no matter when was in the market, their price range is 1,000 level. Maybe 10 years later, 20 years later, still personal computer, the price is around 1,000 level. Looks like. So even my first personal computer was the 2000, around the 2000, the dollar. Interesting is my dad, who didn't know anything about computer at the time, gave me. So it's 1983. The reason was he worked for the bank, so he had a customer who started a business to sell the computer. So he should buy for his customer. So my dad gave me as a gift, birthday gift. Then, but actually I got the price a couple of times from the for the marketing purpose at the time, the LG, it was the LG computer. So same as the Apple computer, is a 16-bit computer. So same as the IBM, and it's almost the same architecture. They copied each other. So, but for marketing purpose, they offer the kind of the programming competition. Then the price is very high. So actually, I pay off almost such a thing. I probably mentioned the first program I got the award was the Angry Bird style, the program. So like there's a point and the obstacle. This I call this is a mountain, and it's randomly created. The width and height is always different. It's randomly. Then there's a target. So you can actually set the two things, speed and the angle. Then shoot. It's like Angry Bird. I should have filed the pattern at the time. But, so this is an old size computer. Their data size is quite small, as you can see. But nowadays, it's my MacBook Pro, but yours is much better than that. And Surface is a higher version. It's a huge difference. That comes with such a different scale of the data. We know up to the terabyte. This is right now the personal computer level, the scale. But the petabyte is for the company, not big company. Big company is the everyday is a petabyte size. They should deal with the exabyte. But total, if we consider total amount of data nowadays, it's the exabyte. So nobody knows exactly, but they actually do survey and estimate the size of data. 2020 is like the 50 exabyte, zettabyte level. What is a zettabyte? It's hard to imagine. But this is there's no way to put the dot, considering the resolution of this computer and the projector. So there might be. And the 1,000 of this dot, invisible dot, is this one, small dot. Over here, this is a petabyte. And 1,000 of that is 1 zettabyte. So then nowadays it is estimated 50 zettabyte level. What about the next 10 years? It will increase. That changes the game rule. So like in data, so if you already took the big data system, so no way to keep such the exa or zettabyte level data in our traditional system, the file system. How can we address such a thing? Distribute. So along the number of servers, we distribute the data. Then we should be able to use such the distributed data. So distributed system is not the new one. We had the distributed data system even before. The problem was the programming. The programming is not easy because the resources are distributed also. Because when you run the program will be loaded into the memory, but memory is not shared. So there's L1 cache, L2 cache. So they rely on the cache, L1 cache and L2 cache. L2 cache in the same chip. It's a layer 2. It's a 4 megabyte, 2 megabyte, 4 megabyte, such a level. But it's heavily used to speed up. But if you distribute the system, they cannot share. The long time before, they try to connect the memory level, memory channel, but still not in the L2 cache level. Even connecting the memory channel is not simple, very, very expensive. So how can we address in the big data system? We adapt the idea of map reduce. So we are going to process. We actually, the traditional system focus on the bring the data to the CPU processor, because processor is the king of the most important component of the computer system. So we thought to process the data, we need to bring the data to the processor through the memory. Because of that, so it's a huge the overhead. We need to communicate to each other. It's a network overhead, and it's not synchronized. What if processing, instead of bring the data to the processor, we are going to process it on the local data. So that means we need to design the program based on the distributed data. It's called the map reduce. So process locally, process locally, process locally. That is the mapping part, and just collect all the data and apply the algorithm that you want. The business logic, like the summation or averaging, that is the reduce. So map reduce has been used, still being used. So nowadays Spark is more popular than the map reduce, but behind the Spark is still map reduce concept, whether or not you realize it. Okay, so and that addressed a lot of problem. So that really changed such a size, the volume of data, change a lot of things. What about the database? So database is struggling also. Relational database, as it's a petabyte size level. So even modeling itself is not simple. So we need to use SADs, unstructured data, semi-structured data, and also the size of data is not. So we need to consider the different the concept. Okay. So I'm going to skip the big data part because the big data course we already discussed. So, but it is true, the birth of the NoSQL database from the big data. The big data changes the data structure and the requirement and the processing part. So then we have the different computing architecture, which is the Hadoop-based system. Then we have the NoSQL database. That's the reason that I put, first time when I offered this class, I dealt with the NoSQL part. But the Hadoop is closely related to the this one. So when we have such a large amount of data, so we had the solution before, but the problem was such a computation part, especially for the memory. So I learned this MPI, such a thing, but nobody knows exactly. It's very hard to optimize. So open MPIs or such a thing. So even to learn the open MPI job, using the distributed system, I need to ask the operator. So it's the algorithm and change the code and run. But there's a field and back and forth. It's not that simple. So nowadays it's a data-driven more. So our data structure should be changed. Should be more flexible. That is the idea of the NoSQL database. So we have, if you already took the big data course, so that is our idea. So then that is what we did to address such a problem. So if you didn't take such a big data course, it will be a good opportunity later to. Okay, so to address the issue of such a big data, we had the existing solution, but that doesn't address it fully. So Hadoop, who invented the Hadoop? So what is a Hadoop? Hadoop is the name of the big data platform to deal with such a big data. Then Google encountered such a problem first, because as I mentioned the history of the Yahoo, Google did the same thing. By the way, the Google was founded before 2000, 1995, 6, something like that. I read the article from the yesterday regarding to the Amazon. Amazon is right now the stock price is high, but the Amazon actually the minus the 10, 15 years. So they actually spend more money than the benefit, profit. But once they settle down the platform, so also Amazon got the benefit of the pandemic, but it's not only because of the pandemic. So it takes a time. Somebody believe nowadays such a .com or the internet-based company or the platform-based company is something jackpot like that. No, they actually spend the time to survive. Sometimes 10 years or the 15 years, and Google had the same issue. So Google way behind of the Yahoo before first time. It looks like the Yahoo is gone. Actually not. Yahoo actually invests the money to the company like the Alibaba. In terms of cash, they are big cash cow to have it. So SoftBank in Japan, the CEO actually suggests the actually invest to the Alibaba and the Chinese company. Then they actually instead of getting the profit from the Yahoo, they actually have invest more money. But anyway, so Google way behind of the Yahoo, but it's at the beginning. But once I think the big part is around the 2000. We have a lot of it's a turning point of the Google to overcome the Yahoo. Then it's only the company in the internet search engine. Based on that platform, expand their business. So like that. Amazon is the same thing. Amazon has struggling. It's not related to musical database, but struggling the 10 years, the 15 years. But the turning point was the high-speed internet. It was late in United States to settle down the high-speed internet or the 4G network. So comparing to other countries. So to open the Amazon, so it takes a time. Nobody wants. But once they have the kind of the infrastructure of the high-speed internet, so it doesn't take a time to open the Amazon website and the search it, and it's very quick. So then the number of the transaction is going high, then they can break the even and the success. So that is the turning point. In case of Google, turning point is like around the 2000. It's the .com company. The boom up a lot. Each company has the customer and make their own website and more the site. So they volume of such a collective by using the crawler is huge. Then they encounter problem of such a big data in terms of document. They collect too much the HTML file. How can we manage? How can they manage? So traditional file system doesn't work. So just a distributed file system doesn't work. So they developed their own file system, which is called the Google File System. That is the kind of father of Hadoop distributed file system. So that is one thing. So we have the architecture to deal with the large amount of data, large amount of document. Then eventually they need to process, like the indexing, searching, and so on. So programming interface, that is not reduced. So Google actually developed the beginning of 2000 such a two things. So new file system and the programming frame. Then interesting is they open. So usually such the commercial company, they hide their domain, the asset. But the Google actually open to the public by publishing the paper. That will be the first reading assignment, Google File System. So then the people like that. then even a lot of companies like the competitor, like the Yahoo, they encounter same problem to deal with. So Yahoo adapted such a Google. The name was changed. So once the Google released a Hadoop, actually it's a Google file system and MapReduce. So Apache Foundation actually adapt the open source project, which is called the Hadoop. That is the starting of the Hadoop. Then the interesting is even the Yahoo, they changed all their platform by the Hadoop system. Even they developed a new programming interface based on the MapReduce, which is called the Pig Latin. Because until that time, all the developer in Yahoo is the Java developer. But they, not Java developer, other language. So Hadoop is based on the Java. So they cannot train or they need to fire and hire the new employee. Instead, they developed a new program language that is the Pig Latin, for example. So that is the short history of the Hadoop. So Hadoop started from to deal with the big data in the internet search engine. The two parts is the file infrastructure, the distributed file system. Another one is the programming interface, as you learn in your big data course. Then after that, huge the business platform software and big data. Like that. This is the old one even. All the company they include the Hadoop in their platform like that. This is IBM the analytic platform. And the Oracle also is an interesting story also. Oracle is a relational database, but they include the part of non-relational database module like the Hadoop and the NoSQL database. Very interesting. Microsoft also. So we have learned such a Apache Hadoop ecosystem. Among them, you can see this one, HBase. So when we learn the Hadoop ecosystem, so Hadoop distributed file system, HDFS, is a file system itself. There is no indexing, there is no update, there is no flexibility because if you provide the flexibility to the HDFS, it will be slow. So you cannot handle network overhead or such an overhead to manage the data. So it's not only the right ones and no update. It's only append and no indexing. That is the HDFS. So it's good for the specific purpose of the data processing, like the batch processing or data warehousing. But the online transaction or the application, they need to update the data. Can I update the data on such a big data system? No. So I'd like to. So that is the starting of the HBase. HBase is the database on top of Hadoop system. Because of that, it's the HBase. First, NoSQL database. So this is not relational database. This is a database based on the Hadoop big data. So we will see. And also HBase provides the flexibility of the data model. It's a column-based model. So we can add, if I want a new column, we can add a column to the for specific data only. We don't have to change the entire model like that. So we will see the HBase source. So this is the summary of what I introduced so far, the history of the world. So relational database, but it has a problem. We will see more details, what kind of problem. I already introduced everything, but this is the starting point. So when we have such a large amount of data, how can the relational database deal with such a large amount of data? The relational database also tried before, like the scale up. However, relational database, one of the benefits of using relational database is a consistency. So it's a transaction management is one of the main characteristics of using such a relational database. But if the database is distributed, so anyway, to simplify the thing, we need to check everything, okay, through the network to keep the consistency. So it takes some time. So until the consistency is confirmed, you cannot let the transaction, other transaction access the data. It will be stopped, it will be hanged, it will be the problem. So relational database, that's the reason, and not designed to be distributed. It can be, there is, but it's not practically, fully implemented. So this is the problem. We need to address that. So in the also NoSQL database. There are two ways. One is partitioning. So partition is implemented, but partition is like it's a table by table. So when we have the larger amount of that transaction, banking transaction, for example, it's a huge. So one is year 2010. It's the same table, but it's distributed. So year 2011 and year 2012. So year by year. It's a history data. It's okay to partition for the table because we are not going to access the entire several years of data, and also it's mostly archive purpose. So last one, the 2020, is mostly accessed. So it's not, it doesn't, it may not have the huge overhead to keep the consistency. Otherwise, the scale up is not the practically available in the relational database model. So, how can we address? So, by proposing more relaxed. So, idea of the NoSQL database is relaxed. We are not going to be serious too much, such a consistency and availability like that. So that is called the Cap Theorem. So we will take a look at it's a theoretical approach of the NoSQL database, which is called the Cap Theorem. Even Google would like to overcome such a Cap Theorem. We will say that is a spanner that you watch just before. To do that, I explained in the database design course ACID, whether or not you remember. So that is the main, the only 4 letter, but that explains the main characteristic of the relational database model. So atomicity, consistency, and isolate, and what is the D? D, later we will see, I forgot. Lack of oxygen. Okay. We will. So one solution is the Dynamo. For example, AWS also each 3 major the cloud computing the provider. One is AWS. So I think more than half, not too sure. So AWS. Then the Google and the Microsoft Azure. So each such a cloud vendor offered their own NoSQL database because the relational data is first expensive. The Oracle is the major vendor, so they don't want to give the money to the enemy. So they try to have their own database, not relational database, because relational database, as we have seen, the very limited. So they try to be flexible. So for example, the AWS offer the Dynamo DB, and then the Google offer the Spanner, and so on. Okay, so it's a good idea to start to read the paper. If you already took the big data, I think the one or So maybe read, but it's a good time to read it. Okay? Then it will be the simpler and easier to understand. Also in terms of NoSQL database. Okay. There's another note. It's the so challenge and opportunity with the big data. I'm not going to explain the use this one. So when you have a time, you can just quickly go over, and will be helpful to understand the big data. So next class we will see the NoSQL database directly based on the introduction. Then the first due of the reading assignment is by the September 11th, and this will be very, very helpful to understand the NoSQL database, especially later we will see the HDF first. So then please submit your the summary by the September 11th. Okay, so let's check any questions so far. Okay, is the reading assignment posted? Yes, it's on the campus. Okay, thanks so much for joining today. Okay, then any questions? And did you share the presentation 5? Yes, so you can go to the Canvas so that you can find the PDF version of the lecture note. Did I record? Oh, yes. Okay, if there is no questions, so thanks so much for coming to the class, and thanks so much for your joining through the Zoom. So we will have the next week, the Labor Day is Monday. So we have class on Tuesday. We will have the class the Tuesday. At the time, I think they're pretty much okay. So we are going to keep the same rule. So half of the student can join the in-person class, and we will have the much like the regular class from the next week. Thanks so much, and thanks so much, and stay safe.